Um, Good afternoon, my YouTube viewers. It's Crystal here. I'm trying to do a code review for you, and this is actually the third time I've started this video. The first time I got a bit flustered about something and I stopped it, and then the second time I got a few minutes into it, and then I had a telephone call, so I had to stop it. So now we're on number 3. You know, they say third time lucky. So we're going to try to do this again. What I'm going to do is I'm going to do a code review for you. But before I do the code review, I need to go through some terms that we're going to be going over in the code review, just so you'll know a little bit about these terms. So the first thing we're going to talk about is hypothesis testing. So we asked the question, what is hypothesis testing in statistics? Hypothesis testing is an essential part in inferential statistics where we use observed data in a sample to draw conclusions about the unobserved data, often the population. So that is what we mean when we say hypothesis testing. In hypothesis testing, you have something called a null hypothesis. So we ask the question, what is null in a hypothesis? A null hypothesis is a type of statistical hypothesis that proposes that no statistical significance exists in a set of given observations. Hypothesis testing is used to assess the credibility of a hypothesis by using sample data. Sometimes referred to simply as the null, it is represented as HO. In addition to the null hypothesis, we also have something called the alternative hypothesis. So we ask the question, what is an alternative hypothesis? An alternative hypothesis is one in which a difference or an effect between two or more variables is anticipated by the researchers. That is, the observed pattern of the data is not due to a chance occurrence. We're also going to be, when we do our hypothesis testing, we're going to be calculating the p-value. So you need to know what a p-value is. And he says, we ask the question, what is the p-value? The p-value means the probability for a given statistical model that, when the null hypothesis is true, the statistical summary would be equal to or more than the actual observed results. So that's our p-value. And I also want you to know where I got my questions that we're going to be going over. I got my questions from this video right here, the Statistics and Probability Full Course by Geeks Lessons. So you'll know where I got my questions. So what we're going to do is we did the questions in R, and we're going to go over one question in R, and then what we're going to do is we're going to go check it out in Python. So we have the first question. I have a coin that is fair. To test this, I flip it 10 times and count the number of heads in these 10 flips. A total of 3 heads actually came up. Is this sufficient evidence that the coin is not fair? So our null hypothesis is p equals 0.5. Our alternative hypothesis is p does not equal 0.5. So we're only going to use for this code review binom.test brackets x equals 3, comma, n equals 10, comma, p equals 0.5. And so we have a p-value of 0.3438. Now what we're going to do is we're going to come over here to Python, and we're going to do the coin flip in Python, and we're going to import scipy.stats as stats. The formula is stats.binom.test brackets x equals 3, comma, n equals 10, comma, p equals 0.5. and then it gives us a p-value of 0.34375. And let's just write this here. So it clarifies that it's a p-value. So that's our first one. So you can see that the p-value is the same. Okay, so now we've got all of our p-values set up so you can see where that they're all p-values. Now we're going to go to our next question. And you can see that the answer was, since the p-value is 0.3438 greater than 0.05, we fail to reject the null hypothesis. So that just means it's accepting the null hypothesis. Now our next question. I contend that more than a quarter of the students at Knox are juniors. To test this, I randomly sample 100 students from the student body asking their class year. In my sample, 30 stated they were juniors. So my null hypothesis is p is less than or equal to 0.25. Our alternate hypothesis is p is less than 0. Or is greater than 0.25. And so the formula in R we use is binom.test brackets x equals 30, comma n equals 100, comma p equals 0.25, comma alternative equals greater, and we have a p-value of 0.1495. And since the p-value is 0.1495, it is greater than the 0.05, so null hypothesis cannot be rejected. So that means they accepted the null hypothesis. So we come over here to Python, and we've got exactly the same code, but, well, the exact answer, but the code is stats.binomTest brackets x equals 30, comma n equals 100, comma p equals 0.25, comma alternative equals greater, and we have exactly the same answer, 0.1495. One thing that I would like to say is, while I was researching this and trying to correct what I thought was an error, I found out that binom_test is actually deprecated, and you're supposed to be using binom test now, because I thought I had a problem, and so I was investigating what I thought was a problem, and that's what I found out when I was investigating it. And so a lot of times when these functions are deprecated, they will still work. The functions will still work when they're deprecated, but at some point they will remove the functions and you won't be able to use them anymore. So that's another good area for computer programs to get into, because they're always changing the libraries, they're always changing the programming language, and they're always changing the libraries. And so you've got to stay up on top of the changes that are made in the programming languages and the libraries. Because if you're writing programs for a company and some of the code that you have written has become deprecated, then that means that at some point in time that code is no longer going to work. So that is another reason why companies want to employ computer programmers, so they can stay on top of the latest trends in technology, and they can fix any code that is no longer working due to the fact that it has been deprecated. Okay, so now that I've said that, I'll go to the next question. So my provided sample of 661 students, of which 22 were freshmen. Given the proportion of freshmen in SCU is 28%, are the data representative in terms of freshmen? The null hypothesis is P equals 0.28, and the alternative hypothesis is P does not equals 0.28. And then so the code that we used, and I went through and I was doing some research to try to correct what I thought was a problem. So I added some bits to this code. So the code is binom.test brackets x equals 22, comma, n equals 661, comma, p equals 0.28, comma, alternative equals two-sided, comma, const level equals 0.95. And we got a p-value of less than 2.2 e to the negative 16, e to the negative 16. And that's where I got confused, because the answer that I got on Python was not that. And so I spent a lot of time trying to research it. But the answer is the p-value is less than 2.2 e to the negative 16. It didn't say it was equal to, and that's where I got flummoxed. So since the p-value is less than alpha equals 0.05, we reject the null hypothesis in favor of the alternative. So this is one area where it's not accepting the null hypothesis, it is rejecting it. And so now we're going to do the question. First thing we're going to do is, because I did it twice, I did it twice because it wasn't, I felt that it wasn't coming up the same. And since I felt that it wasn't coming up the same, I was trying to find different ways to write the code to try to make the code the same. And I went into the documentation and I couldn't find anything in the documentation. And then finally I saw that the p-value was less than. It didn't say it was equal to, it said it was less than. So that was good. So the first solution we have is scipy.stats as stats. So stats.binom.test brackets 22, 661, 028, alternative equals two-sided. So that's the most current version of the code that you are supposed to be using, because the code that I showed you in the earlier example, that's been deprecated. And then so we had a p-value of 6.9 to the negative 63, which is not the same as 2.2 to the negative 16, but it's definitely less than 2.2 to the negative 16. And then the next thing we're going to look at stats models. And the reason why, the thing about stats models is, stats models had originally been part of SciPy. And then at some point they decided to take stats models out and make it an entirely different library. So you've got SciPy that enables you to do statistics, and stats models that enables you to do statistics. But because I was trying to solve what I perceived to be a problem, I dug out the stats models as well. Because if you'll notice, if you've been watching my videos, you notice that I've been doing a lot with SciPy. Well, in this particular solution, we're going to be using stats models, and the code is binom_test brackets 22, 661, 0.28, alternative equals two-sided. And it gives you a 6.9 to the negative 63, so it gives you the exact same value that you got from SciPy. But I decided to go ahead and include that, and the reason why I wanted to include that was because just to show you that I was trying to solve these problems and you can do it with stats models as well as SciPy. And we'll go to the next question. It says, I would like to determine if the proportion of males who wear hats is the same as the proportion of females who do. To test this, sample 100 males and 100 females. 10 males and 16 females were wearing hats. So the null hypothesis is the PF equals PM, so that's female equals male. And the alternative hypothesis is PF does not equal PM. And the code that we use is prop.test brackets x equals c brackets 10, 16 brackets, n equals c brackets 100, 100 brackets, and then you get a p-value of 0.2931. So since the p-value is 0.2931, being greater than an alpha of 0.05, not 0.5, 0.05. So we fail to reject the null hypothesis. And then so we come over here, and we're using SciPy, and I will say that I had some problems with this, and I had to actually go into Stack Overflow and ask for some assistance in Stack Overflow. And so I got the answer with Stack Overflow, and the reason why is because the value that I came up with was not the same value that was in R. And in addition to that, it was not the same value that I came up with as R. And so I was quite confused. So I did actually have to go to Stack Overflow and ask the question, and I'll show you the question here. This is the question right here if you're interested. So that's our question, and I did get an answer to it. So we're importing SciPy stats as stats. So hats equals NP array. We make an array of 90, 10, and 84, 16. So because you had 100, so 10 minus 100 is 90, and 16 minus 84, so 100 minus 10 is 90, and 100 minus 16 is 84. And so that's how you come up with that array. And stats.type2 underscore contingency hats, correction equals true 1. And then we just say right here, answer equals And then so we do it. We say stats.try2 underscore contingency bracket hats, correction equals true, and then it says 1. And it's print hats SciPy p-value underscore stats.try2 contingency hats. And we have a p-value of 0.29312, which is the same that we got in R. So that's what we want to see. And so the p-value is greater than alpha of 0.05. So we failed to reject the null hypothesis because what we're looking for is when we do something in R, we're looking to translate it into Python and make sure that we have exactly the same code in Python, or the same answer in Python that we have in R. And so that's basically what we're looking for, and that's what we did in this code review. So I just wanted to show that to you and show you all the answers and show you that I put forth a lot of effort to make sure that I made the code as correct as I possibly could so that I could do this code review. So I'm going to go ahead and conclude the code review because we've covered all of the questions and we've covered all the solutions in both R and Python. So I'm going to finish now. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you for watching my code review and helping me build up my channel. And I look forward to communicating with you in the next video.